In this question, we have two objects, two train cars, that are approaching each other. So this is photo 1. So one of these train cars has a mass of 1.5 times 10 to the 5 kilograms, and the other one has a mass of 1.1 10 to the 5. I'm going to write it outside so that it's a little bit clearer. The train car at left is moving rightwards at 0.3 I hat meters per second. More about that I hat in a second. And this one is moving leftwards at 0.12. Eventually, they are going to collide with each other. The point of collision, I'm going to set my origin there. And I'm going to set rightwards as being x. And because I've set rightwards as x, that means that the velocity of the first car is positive, but the velocity of the second car must be negative. All right then. This is enough information for us to figure out what the final velocity of the two cars is going to be. Remember, these two cars are going to stick together so they have the same final velocity. Let's go ahead and let us solve for what that could be. According to conservation of momentum, the total momentum in photo 1 equals the total momentum in photo 2. So the momentum of the 1.5 kilogram 1.5 times 10 to the 5 kilogram train car plus the momentum of the 1.1 10 to the power of 5 kilogram train car in photo 1 is equal to the momentum of the 1.5 10 to the power of 5 kilogram train car in photo 2 plus the right train car, which is the 1.1 10 to the power of 5 in photo 2 as well. Let's expand this still further. The mass of the 1.5 times 10 to the power of 5 kilogram train car times the velocity that it has in photo 1 plus the mass of the 1.1 times the velocity of the 1.1, both in photo 1, is equal to the mass of the 1.5 times the velocity of the 1.5 in photo 2 plus the mass of the 1.1 in photo 2 times the velocity of the 1.1 in photo 2. Okay, now let's start plugging in all the information that we have. 1.5 times 10 to the power of 5 multiplied by a velocity of 0.3 I hat plus 1.1 times 10 to the power of 5 times a velocity of negative 0.12 I hat is all equal to 1.5 times 10 to the power of 5 times an unknown final velocity plus 1.1 times 10 to the power of 5 times its unknown final velocity. However, we do know that these two velocities are the same because these two train cars have hooked together. Let us start simplifying this. 1.5 times 10 to the power of 5 times 0.3, that gives us 45,000. (1.1) times 10 to the power of 5 multiplied by negative 0.12 gives us negative 13,200. And this velocity I'm going to factor out. That's going to be my v final. and I have 1.5 times 10 to the power of 5 plus 1.1 times 10 to the power of 5 on this right side. Let's continue simplifying. 45,000 plus negative 13,200 gives us 31,800. Is equal to final velocity multiplied by 1.5 times, or sorry, 1.5 plus 1.1 will give us 2.6 times 10 to the power of 5. So it's just a matter of division. The final velocity is equal to 31,800 divided by 2.6 times 10 to the power of 5, which is 0.122. I hat meters. So that there is the final velocity of these two train cars. They're going to move at 0.12 meters rightwards. In this question, a bullet is going to strike a box. The bullet has a mass of 0.2 kilograms. The box has a mass of 1.5 kilograms. This here is photo 1. The bullet is initially moving at 400 meters per second. The bullet is going to embed itself in the box, and the two of them are going to move together following that inelastic collision. We can probably predict that these two are going to move to the right, but we have yet to figure out what velocity they will have when they do so. Now this question had 4 parts to it, so let's solve each of these in turn. A was to find out what is the final velocity of this box-bullet combination in photo 2. So the way that we do that is using conservation of momentum. The total momentum in photo 1 equals the total momentum in photo 2. The momentum of the bullet, I'll symbolize the bullet with a lowercase b, plus the momentum of the block in photo 1, I'll symbolize the block with an uppercase b, a capital B, is equal to momentum of the bullet in photo 2 plus momentum of the block in photo 2. Expand still further. The mass of the bullet times the velocity of the bullet in photo 1 plus the mass of the bullet, the mass of the block times the velocity of the block in photo 1 is equal to the mass of the bullet times the velocity of the bullet in photo 2 plus the mass of the block times the velocity of the block also in photo 2. Now, let's substitute in all the information that we know. The mass of the bullet is 0.2. The velocity of the bullet was 400 I hat. Oh dear Lord, I just realized that I haven't actually put in my axes. I'm going to set rightwards as being the positive direction. So the motion of this bullet would be 400 meters per second I hat, that is the positive direction, plus mass of the block, 1.5, times velocity of the block, 0, is equal to mass of the bullet, still 0.2, velocity of the bullet in photo 2, unknown, plus mass of the block, which is 1.5, times velocity of the block in photo 2, which is also unknown. So we can simplify this. 0.2 times 400, that's going to give us 80. So this entire left side simplifies down to 80 because 1.5 times 0 is obviously 0. So we get 80 I hat is equal to, these two velocities are the same. So that's going to say final velocity times 0.2 plus 1.5. Simplify still further. V final is equal to 80 I hat divided by 0.2 plus 1.5 is 1.7 is equal to 47.06. So this is the final velocity of the bullet, and it is also the final velocity of the block. Okay. So far, so good. Now, let us find out what the impulses are. So part B was asking us to find the impulse of the block on the bullet. So impulse is going to be equal to the momentum of the bullet in photo 2 minus the momentum of the bullet in photo 1. So that works out to 0.2 multiplied by the initial velocity of the, the final velocity of the bullet is 47.06 I hat minus 0.2 times the velocity of this bullet immediately after or immediately before the collision was 400 I hat. And that works out to 0.2 times 47.06 minus 0.2 times 400 is negative 70.58. And because this is an impulse, this would be measured in kilogram meters per second. So that is the impulse of the block on the bullet. It's a negative impulse. It's a leftward impulse. It slows down the bullet in the rightward direction. What about for the impulse of the bullet on the block? That would be the momentum of the block in photo 2 minus the momentum of the block in photo 1, which works out to mass of the block, 1.5, times the final velocity of the block, that's 47.06, minus 1.5 times the original velocity of the block, which was 0. So all of this works out to 1.5 times 47.06, or if we want to be really rigorous about it, 0.088, it comes out to 70.588. In fact, it works out to exactly the same thing, but positive. And that makes sense, because these two objects, when they interacted with each other, they must have exerted equal and opposite forces on each other. And whenever you have equal and opposite forces, that also means you must have equal and opposite impulses. The last step was to find out what was the average force of the bullet. Now, impulse is equal to average force multiplied by time. The impulse of the bullet on the block was 70.58, and correctly, this was negative 70. This should be I hat. This should also be I hat kilogram meters per second. So 70.58 I hat kilogram meters per second is equal to the average force times a time of 0.003 seconds. That's what we were told. The collision lasted for 0.003 seconds, 3 milliseconds. Which works out to 23,529. So the average force is 23,529 I hat newtons. And this is the force that the bullet exerted on the block, on average, during the time that it took for them to collide, which was 3 milliseconds. In this question, we have a person who is standing on an icy surface and who is holding a football. Then the person throws the football. Photo 1 is while they're holding the football. Photo 2 is after the football is thrown. The person throws the football at 6.7 meters per second. The mass of the person is 65 kilograms. The mass of the football is 1 kilogram. I'm going to set rightwards as positive. So the final velocity of the football is 6.7 I hat meters per second. And now we can solve for the velocity of the person going backwards. So let us use conservation of momentum here. The total momentum in photo 1 equals the total momentum in photo 2. The total momentum in photo 1 is the momentum of the person plus the momentum of the ball in photo 1, which is equal to the momentum of the person in photo 2 plus the momentum of the ball in photo 2. Expand it out still further. Mass of the person in 1 times velocity of the person in 1 plus mass of the ball in 1 times velocity of the ball in 1 is all equal to mass of the person in 2, velocity of the person in 2, plus mass of the ball in 2, velocity of the ball in 2. Substitute in what is known. Mass of the person, 65. Velocity of the person, 0. Plus mass of the ball, 1. Velocity of the ball, 0, is equal to mass of the person, 65. Velocity of the person, unknown. Plus mass of the ball, 1. Velocity of the ball, 6.7 I hat. Very simple. The entire left side works out to 0. Is equal to 65 times velocity of the person in photo 2 plus 6.7 I hat. Move this around, subtract 6.7 I hat from both sides, and I get 65 times velocity of the person in photo 2 equals negative 6.7 I hat. Velocity of the person in photo 2 is equal to negative 6.7 I hat divided by 65, which gives us negative 0.103. So this is the person's final velocity. This is how fast the person is going to recoil after throwing the ball on an icy surface.